Space. Timeless. Infinite. Eternal. For countless millennia, the stars and planets traveled their silent paths in perfect harmony. It was called Orpheus, the meteor. Its power is greater than all the hydrogen bombs. Its speed is greater than any rocket ever conceived. Its force can shatter continents. Its mass can level mountain ranges. It cannot think. It cannot reason. It cannot change its course. And it's going to strike the Earth in 6 days.
Hello, I am Andrew Gobus, and this is my presentation about near-Earth objects and impact events. The preceding clip was from the trailer for the 1979 film Meteor. I included it mainly for the opening narration, which I think pretty well encapsulates the threat of these objects and why we must deal with them. These events have the potential to change life on this planet forever. They've done so in the past at least a couple of times, and the Earth will eventually be struck again by a large object of space, and we need to be ready for it. The creation of the solar system left a lot of leftover bits flying around. They're estimated to be between 1 and 2 million large asteroids in the area between Mars and Jupiter, and while most of these stay put, occasionally they get knocked around, sometimes by one of the roughly 6,400 comets that are moving through the solar system, and they end up a lot closer to Earth. If the perihelion distance of an asteroid becomes less than 1.3 astronomical units, they fall into the category of near-Earth objects, or more specifically near-Earth asteroids. Comets that fall under that distance and have an orbital period of less than 200 years are termed near-Earth comets. Most of the near-Earth objects out there actually pose no threat to the Earth at all. For an asteroid to be considered potentially hazardous, their perihelion distance would need to fall under 0.05 astronomical units, or about 7.5 million kilometers, and have an absolute magnitude of less than 22, or roughly a mean diameter of more than 140 kilometers. There are currently about 2,000 known potentially hazardous objects. While objects smaller than that may still be dangerous on a more local level, the objects termed potentially hazardous pose a threat minimally at a regional level. This image shows the location of the roughly 18,000 known near-Earth objects, which accounts for about 90% of what is out there. The current rate of discovery is about 40 new objects per week. The potential energy released by an impact event is a function of the object's size and velocity, so the bigger and faster the object, the more destructive its power. The impact of an object of 150 meters could have the strength of 288 megatons of TNT, or a much smaller object of about 10 meters could have the strength of around 100 kilotons of TNT. For perspective, the bombs dropped on Hiroshima and Nagasaki were about 15 and 20 kilotons of TNT respectively. Smaller objects like that from Russia in 2013 can cause significant damage without even impacting the Earth, and most of the deaths from a potential event might not even be caused by the impact itself. The wind generated from airbursts as well as smaller impacts is enough to cause significant casualties. As the size of the object rises, heat and pressure generated by the impact as well as the amount of debris launched into the air become significant threats to life, and should the object impact the water, a tsunami would more than likely be generated that could easily kill thousands. An object of about 400 meters with all of the aforementioned effects could potentially harm over 250,000 people. The impact of an object over 100 meters in an urban area could lead to millions of casualties. The 1908 event in Tunguska, Russia, affected an area of over 2,000 square kilometers, which is larger than the cities of Berlin and Paris. It brought down roughly 80 million trees and was caused by an object between 30 and 50 meters exploding 8.5 kilometers above the Earth's surface. The good thing is that smart people are taking these objects seriously. NASA's been studying them since the 70s, and in the 90s the US Congress actually mandated they find most of what is out there. The Sentry and Scout programs are providing data on objects 100 years out to a few hours away. The European Space Agency has similar programs such as their Space Situational Awareness Operation and the NEOShield 2 program, which work to find, directly study, and remove the potential danger of these objects. The non-governmental B612 Foundation is a group of scientists, astronauts, and engineers working on similar goals as those of NASA and the ESA. Their Asteroid Decision Analysis and Mapping project operates similar to Sentry and Scout, and they've done research showing the feasibility of using nuclear weapons to nudge objects out of the way, as opposed to trying to destroy them outright, which probably wouldn't work and might make things worse. The threat that near-Earth objects pose to Earth is very different than many of the other natural hazards we face on this planet. Unlike earthquakes, tsunamis, and volcanic eruptions, they are reasonably manageable. But this is a threat that affects the entire planet. Like the trailer from Meteor mentioned, these are objects that cannot think, reason, or change their path on their own. That means that it is on us, as beings that are capable of thought and reason, to change their path for them.